All right, we're off and running. Okay, so practical circuits. Receivers, transmitters, transceivers, and transverters. Early on, receivers and transmitters were separate entities. And for those of you who got my card there, look at the picture on the back of that card, and that's a vintage Collins receiver. So back in those days, you had a receiver and you had a transmitter. And because you had separate units like that, you had to have a switch that goes back and forth because you definitely didn't want to transmit into your receiver. So you had to have a switch to make sure that it switched over when you press the push to talk button. A transceiver is a device that combines both the transmitter and the receiver. A transverter is a device that can convert HF signals, HF transmit and receive signals into UHF, VHF bands or beyond. I don't know anybody that uses a transverter. What is a transceiver? Alpha, a device that combines a receiver and transmitter together, all in one. What device converts the RF input and output of a transceiver into another band? So it didn't specify that it was HF going to VHF, UHF, but we did in the description, right? So what device converts the RF input and output of a transceiver to another band? Charlie, the transverter. Power amplifiers. Typical transceivers have the following power outputs. Okay, so your handhelds normally have 5 watts. Both of these are 5 watts. There are some that are 8 and some that claim to be 8 and some that claim to be 10. When measured, they're actually falling a little bit short, and these are no exception here. They're probably going to end up putting out 3.5 to 4 watts real power. Base HF transceivers are typically 100 watts. There are more and more being produced that are 10 or 20 watts. And usually they do pretty good. An RF power amp can be used to increase power up to the legal limit. Have we mentioned the legal limit yet? Okay, your legal limit is 1.5 kilowatts. It's 1,500 watts. And you can get a power amplifier to take you, well, you can get a power amplifier to take you higher, but you're not allowed to. But yeah, they're available out there. There are ingenious people that build things. But your base HF transceivers are typically 100 watts. I think there's a couple that I've seen that are 200 watts, but they're also a lot of money. An RF power amplifier can be used to increase power up to the legal limit. RF power amplifier may have a mode switch to set power output for the operating mode. What device increases the transmitted power output from a transmitter? Bravo, an RF power amplifier. Very good. What is the function of the single sideband CWFM switch on a power amp? That was the last. Sorry. Bravo, set the amplifier for the proper operation in the selected mode. 2 of the most important transceiver specifications are sensitivity and selectivity, and we're going to discuss the differences here. Sensitivity is the ability to detect a signal from the noise and garbage that it will inevitably accompany it. That's what sensitivity is, the minimum power level at which the receiver can clearly receive a signal. An RF preamplifier can improve sensitivity, installed between, your RF preamplifier should be installed between the antenna and the receiver. Selectivity. Selectivity is the ability to discriminate between 2 or more signals. The way single sideband and FM works is different. On these here, only the strongest signal will be heard. Only the strongest signal will be heard. On your single sideband, you can hear more. You can hear everybody that's there that's got a signal that will come into you. And sometimes you have to discern between them. So selectivity is the ability to discriminate between two or more signals and capability to detect and clearly receive a wanted signal. And I can't see the rest of that there. Which term describes the ability of a receiver to detect the presence of a signal? Receiver to detect the presence of a signal. Sensitivity, yes, that is correct. Which term describes the ability of a receiver to discriminate between multiple signals? Charlie, selectivity. Where is an RF preamplifier installed? Alpha, Michelle, between the antenna and receiver. Very good. And let's see, AM receivers. Does anybody listen to AM anymore? What's that? Okay. All right. So tuned RF, TRF, one of the simplest designs. Your RF signal is amplified until it's large enough for demodulation. The disadvantage is wide bandwidth and low selectivity. This is old technology here. And sometimes this is technology that's hard to keep in tune because you see this dotted line right here. That's a mechanical linkage between three stages. And sometimes those are hard to keep lined up, especially when pilots slam their aircraft down into the deck because they don't want to miss the wire. So, super heterodyne. This is what the modern, semi-modern technology. It's been around for a while, but this is probably what most receivers are. The most popular RF signal is converted to one or more intermediate frequencies. Narrower bandwidth and higher selectivity is the benefit. So you notice there's only one linkage there, and much easier to keep it going properly. So you've got an RF filter out here on the end and a preamplifier. The preamplifier has to put enough power on it so that it can be managed by the mixer to be able to pull off the audio frequencies, or the intermediate frequencies rather. And then you have your demodulator that, after the IF stage, after you get your IF, then you've got another amplifier stage, and then your demodulator breaks it down into an audio signal. Direct conversion, I think there's two different versions of SDR, but this is a direct conversion SDR. Most of your modern radios are going to be SDRs. That's pretty much everything. Direct conversion, software-defined radio, only limited by the analog to digital converter and processor power. So the faster you can convert from analog to digital and from digital back to analog, the better off the radio is. Software defined, and the drawing is kind of hard to see, but there's nothing from that drawing that's on the test though. But you see, you've got here you've got the antenna, and then you've got a, what's that say? RF. Well, it says RF hardware. But anyway, you've got, what I wanted to point out to you is it's got converters that go both directions, or a converter for each direction. You've got an analog to digital and a digital to analog. So when it's coming in, you're going from analog and you've got to convert it to digital so that the radio can manage it. When it's going out, it has to go from analog back, or from digital back to analog. And at some point down here, okay, I don't see it on there. I might be thinking of something else. But anyway, that is your SDR, and that's most of what you're going to see out there today. The Xiegu 60 G90 that I have is an SDR. Another popular radio is a FX4CR, is a little tiny QRP radio. It's an SDR. There's tons of them out there, from the lowest all the way, lowest prices all the way up to the highest. A lot of SDR radios. Let's see. Super heterodyne receivers use a mixer circuit to convert a radio frequency, RF signal, into an intermediate frequency. Remember, you have your mixer takes in two frequencies, and on the output, you have the original two frequencies plus the sum plus the difference. That's what you have available, and you have to filter. You're going to have some filters there that let you take the signal that you want off of it. So you've got your input signal there on the left, and your local oscillator frequency, which is going to be a fixed frequency. And then on the output, it mixes them up together. What does that say? Ideal mixer or multiplier. So, and then on the output, you're going to have some filters that put everything else to ground and let you take off just the part that you want. Okay, so here's how your mixer, this is a little bit more complicated, but best description. You've got your IF frequency way down here at the bottom, and then your RF that's going out, and you're going to mix them together. When you mix them together, you have your IF, remember, some difference, and both originals. So on the output, you're going to have the two originals and the sum and the difference. And then you just, through a series of filters, you'll pick off whichever one it is that you want to use. Okay, which of the following is used to convert a signal from one frequency to another? Bravo, a mixer. Super heterodyne receivers use a local oscillator circuit to generate a radio frequency signal of a specific, I think it says frequency. Yeah. Okay, and a local oscillator, that's all that is an oscillator right there. And it's controlled by the frequency of the oscillator, in that particular drawing is controlled by C1, the variable capacitor. Just so that nobody gets alarmed, I've got an alarm set for 3:50 on here. That's my 10-minute warning to let me know we need to be wrapping it up. What is the name of a circuit that generates a signal at a specific frequency? Delta, an oscillator. Let's see, AM transmitters, modulator. The AM FM transmitters use a modulator circuit to combine a speech signal with an RF carrier to perform modulation. And we went over that a few weeks ago, right? Amplitude modulation, there's an example of amplitude modulation. You've got your message signal, which is your glorious voice going in on one side, and you've got your carrier signal going in on another side. And on the output, you have that circus over there on the right-hand side. That's your modulated AM output. Which of the following describes, and why are we going back to AM? Because we're single sideband. Single sideband is all about AM, or at least it's 50% about AM, right? Which of the following describes combining speech with an RF carrier signal? Charlie, modulation. You guys listen excellently. Transceivers, a device that combines a receiver and a transmitter. Back in Flintstone days, they had to have separate receivers and transmitters, right? Okay, the transverter is a device that converts the RF input and output of a transceiver to another band. Power amplifier increases the transmitted power output from a transmitter. You can take it all the way up to 1.5 kilowatts, or you can just add another 500 watts, or one of our local friends here has an 800 watt amp that he uses. Sets the your single sideband CWFM switch sets the amplifier for the proper operation in the selected mode. Receivers, terms we want to know about in the receivers are the sensitivity, the ability to detect the presence of a signal amongst all the garbage there. Selectivity, the ability to discriminate between multiple signals. The RF preamplifier, which is installed between the antenna and the receiver to give it a little boost, to help out your receiver a little bit. The mixer, which is used to convert the signal from one frequency to another. The oscillator generates a signal at a specific frequency. Modulation is combining speech with an RF carrier signal. Any questions? And let's see, it is 3:48, so we're going to go ahead and end